A year is randomly selected from Gregorian calendar. Find the probability that it contains 53 Sundays in it. You are watching Brain Exploders, the world where brain starts working. We know that one common year has 365 days and one leap year has 366 days in it. So, in a common year, there is one extra day after 52 weeks, and in a leap year, there are two extra days after 52 weeks. Therefore, there is any one particular day in a common year which is 53 in number, and there are any two particular days in a leap year which are 53 in number. For example, if a common year starts with Monday, then it contains 53 Mondays, but if a leap year starts with Monday, then it contains 53 Mondays as well as 53 Tuesdays. The question arises, how can we say whether a year is leap year or not? Every year that is exactly divisible by 4 is a leap year, except for years that are exactly divisible by 100, but these centurial years are leap years if they are exactly divisible by 400. For example, 2004, 2008 and 2012 are leap years because these are divisible by 4 but not by 100. 1700, 1800 and 1900 are not leap years because these are divisible by 100 but not by 400. Year 1600 and 2000 are leap years because these are divisible by 400. This means that in 400 consecutive years, there are 97 leap years. Before starting the question, we should know how the day of 1st January changes with the change in year. Year 2001 starts and ends with Monday. Year 2002 starts and ends with Tuesday. Year 2003 starts and ends with Wednesday. Year 2004 starts with Thursday but ends with Friday, and that's why year 2005 starts with Saturday. In simple words, a year next to a common year starts with next day in the counting of days, but a year after a leap year starts with the next second day in the counting of days. If all century years also were leap years, then this pattern would repeat after every 28 years. Since 3 out of 4 century years are not leap years, that's why whenever a common century year comes, this cycle of 28 breaks. To get a sample space in our problem, we should know that after how many years this sequence of days repeat. Number of days are 7 and every 4th century year is a leap year. So at first we think that this sequence of day may repeat after 2800 years. But in actual this is not so. So let us find this interval of repetition. Year 2001 starts with Monday. From 2001 to 2101, there is a difference of 100 years, out of which 24 are leap years. Add 100 for all years and 24 for leap years. We get 124, which on division by 7 leaves remainder 5. Fifth day after Monday is Saturday. Hence, 2101 starts with Saturday. Similarly, 2201 starts with Thursday and 2301 starts with Tuesday. From 2301 to 2401, there are 100 years, out of which 25 are leap years. Therefore, instead of Sunday, it starts with Monday. This sequence of days will remain same for next 400 years also, and hence we can conclude that calendar repeats after every 400 years. From 400 consecutive years, we have to count those common years which start with Sunday and those leap years which start with either Saturday or Sunday. It is easy to count if there is no century year, as we know that if there is no century year in our data set, then calendar repeats after 28 years. So let us divide this set of 400 years. From 2001 to 2084, 2101 to 2184 and so on. There are 12 years starting with Sunday and 3 leap years starting with Saturday. But for rest of the intervals, we have to somehow count them. Between 2001 and 2085, there is a difference of 84, which is a multiple of 28, and there is no century year also. Therefore, 2085 starts with Monday. Count 5 days from Monday, we get Saturday. Hence, 2185 starts with Saturday. Similarly, 2285 and 2385 start with Thursday and Tuesday respectively. Now we can determine the starting days of all remaining years in our data. Write these years in the front of days, skipping the day after leap years. From 2085 to 2100, there are 2 years starting with Sunday and no leap year starting with Saturday. From 2185 to 2200, there are 3 years starting with Sunday and no leap year starting with Saturday. From 2285 to 2300, there are 3 years starting with Sunday and no leap year starting with Saturday. From 2385 to 2400, there are 2 years starting with Sunday and 1 leap year starting with Saturday. In total, there are 71 favorable years. Therefore, probability that there are 53 Sundays in a year is 71 over 400, and this was our solution. We have a bonus question for you. What is the probability that a randomly selected year starts with Sunday? We will discuss it in another video. Let's move to our another question. If a, b, c, d and e are 5 non-negative integers less than or equal to 7, then find the total number of solutions for a plus b plus c plus d plus e is equal to 21. Try this question and comment as the solution, and if you have any question like this, then please share with us. Don't forget to like and share our video, and for more such videos, subscribe to our channel Brain Exploders. Thanks for watching.